All right, welcome everybody. Today we're going to talk about Calc Lesson number 42, and this is the fourth day of optimization. Just like every previous lesson about optimization, there's a theme, and the theme of today has to do with the volume and surface area of cylinders or shapes that involve cylinders. So again, these are the same problems that you have on your worksheet. I added a couple of pictures for you, which you might want to go ahead and draw, and then I made it a little bit larger so it was easier to see. So only two problems for today. So we're definitely focusing on quality over quantity, and we're going to keep that same idea for tonight's homework. So here in number one, a container in the shape of a right circular cylinder with no top, so that's kind of the first important thing, there's no top, has a surface area of 3 pi square feet. So again, surface area is the first piece of information that we know, so we know that it has something to do with that. Then what are they looking for? They're looking for both the height and the base radius r that will maximize the volume of the cylinder. So we have yet another quantity we have to find here, which is the volume. So again, whenever you're approaching these optimization problems, read carefully, circle, highlight all the important information. If there's a picture that makes sense, you should draw it. So obviously in this case, over on the left, I have myself a nice right circular cylinder. So you might want to go ahead and draw one for yourself. So what we're going to go ahead and start with is the idea that the thing that we are trying to actually maximize is the volume. So again, the volume, since that's what I'm trying to maximize, means that that's what I will eventually be taking the derivative of. So again, sometimes also referred to as the primary equation, primary because it's the most important one, the one that you're actually taking the derivative of. So if we take a look at our cylinder over here on the left-hand side, if you try to remind yourself of the formula for the volume of a cylinder, remember that a cylinder is made up of a circle and then a bunch of which that are actually stacked on top of each other. So if you remember that the area of a circle is pi r squared, if you then stack a bunch of them on top of each other, that would be equivalent to the height of the cylinder, which means the volume of the cylinder is pi r squared h. Remember, you don't have to memorize anything this year really at all, or really you wouldn't have to memorize them regardless. But as we kind of highlight the important formulas throughout, maybe make yourself a list or certainly just make sure that they're easily accessible. So that's our first equation. And then the second piece of information that we know here has to do with the fact that we're talking about surface area. So in order to find the surface area of a cylinder, you can see that I kind of unwrapped it. That's called a net, if you remember back from your geometry days. But if you were to unwrap that cylinder, you would basically have a rectangle, and then you would have two circles, one on the top and one of the bottom. So for each of the circles, the radius would, of course, be the distance from the center to the outside. Something to remind ourselves of is that there's no top on this cylinder, so we're essentially going to eliminate one of those circles. So then we need to find the surface area for anything that remains. So we're going to use SA for surface area. So starting with the area of the circle, which again, we just went over, the area of a circle is pi r squared. Kind of color code that for you. So pi r squared. And then you have to add the area of this rectangle. And again, if you're taking the cylinder and you're unwrapping it, if you unwrap around, that would be the circumference of the circle, which would be the 2 pi r. And then the height would be the distance of the width there. So if you were going to go ahead and find the area of that rectangle, it would be length times width, which would be 2 pi r h. So this right here is the formula for the surface area of this right circular cylinder. And just something to point out for future problems, this will always be the surface area of a right circular cylinder if there's no top. If there was a top, that means you would have a second circle, which means that instead of having pi r squared, you would have 2 pi r squared. So again, in this case, because there's no top, that's why it's just pi r squared. But please keep in mind in the future, you might have to change it from problem to problem. So now that I have both my surface area equation and I have my volume equation, two variables and two equations, that's a system, which means I'm going to have to use some kind of substitution. So again, because volume is what I'm trying to maximize, that means I'm going to have to resolve something about the surface area. And so far, I have not yet used the fact that the surface area is 3 pi. So I'm going to go ahead and say 3 pi is equal to pi r squared plus 2 pi RH. There's some very good and hopefully obvious news, the fact that everybody has a pi. So I'm going to go ahead and just get rid of those. So 3 equals r squared plus 2rh. Then from here, you have to solve for either r or h, and hopefully it makes sense why you should solve for h, because of the fact that h, there's only one of them, where there are multiple r's. So first, you're going to subtract r squared. Then you're going to divide by 2r. So you're going to get that 3 minus r squared over 2r is going to be equal to h. So again, this is what you might call your secondary equation, because it's the one that you ultimately have to plug back in. So I'm going to take this h and I'm going to substitute it in here for this h. I'm going to move to the side so that I have a little bit more room, but just give you a second in case you're copying any of this down. So the volume, when I make that substitution, is going to be equal to pi r squared times 3 minus r squared over 2r. Remember that we are going to ultimately have to take the derivative of this, so you want to put it in kind of the friendliest manner possible before you do that. So I am going to both distribute that pi r squared and then also break it up into two different terms. So that's going to give me 3 pi r squared, and that's going to be over 2r. Then I'm going to get minus pi r to the fourth over 2r. Then from here, I'm going to go ahead and reduce a little bit. So notice that I can reduce one pair of r's in the first expression, and then I can reduce a pair of r's in the second expression. So now a simplified version is 3 pi r over 2 minus pi r cubed over 2. Yet another simplification step that I can do is to take 3 pi r and recognize that 3 pi over 2, that whole value is a constant. So I'm going to make sure that I separate that from the r so that I remember that. And then minus 1 pi over 2 r to the third. Again, you want to put yourself in the most friendliest fashion possible for which to take the derivative. So again, as I go to do that now, please just make sure you remember 3 pi over 2 and 1 pi over 2, those are both constants. So you should treat them as such when you take your derivative. So v prime would be equal to 1 times 3 pi over 2 is 3 pi over 2. R to the 1 less power means it would disappear. Minus 3 times pi over 2 would be 3 pi over 2. And then r would go to the 1 less power. Of course, we need to now set this equal to 0. Then I'm going to go ahead and put them on opposite sides. So if I put them on opposite sides, I'm going to get 3 pi over 2 is equal to 3 pi over 2 r squared. The 3 pi over 2's on each side cancel. On the left, you would just get 1 and then r squared. To get rid of the squared, go ahead and take the square root. Whenever you take a square root, it should be plus or minus. But the fact that you are talking about the radius of a cylinder, hopefully it makes sense that you should only choose the positive version. So the radius of this cylinder is 1 foot. And if you go back and look at the original problem, that is one thing that they wanted you to find. The second thing that they wanted you to find was the height. So if you go back and look carefully, you have an expression that's h equals. So h equals 3 minus r squared over 2r. You're going to go ahead and plug in a 1. So 3 minus 1 over 2 times 1. That's going to give you 2 over 2, which means that not only should you have a radius of 1 foot, but you should have a height of 1 foot. So kind of seems like an awful lot of work for answers that turn out to be 1, but that's half the fun. So those are your final answers. And again, if you go back to the problem, just to make sure that you have in fact done what they asked, what height h and base radius r will maximize the volume. So it turns out that if you have a cylinder with a radius and a height of 1 foot each, you're going to go ahead and get the maximum volume. All right, here in problem number 2, we have a slightly more complicated shape, which means we'll have a slightly more complicated equation and slightly more complicated work, but still nothing that I don't think we can handle. So a solid is formed by adjoining 2 hemispheres. So as a reminder, a hemisphere means half of a sphere. To the ends of a right circular cylinder. The total volume of the solid is 12 cubic centimeters. What is it that we're looking for? We're trying to find the radius of the cylinder that produces the minimum surface area. So something to point out here that even though this is a separate shape, we're still talking about volume and surface area. In this case, because we're trying to minimize the surface area is going to be your primary equation and the one you have to take the derivative of, where the volume is going to be your secondary equation, and that's the one you're going to plug in. So remember, as you go through the rest of this unit, whatever it is you're trying to minimize or maximize, that has to be the one that you ultimately take the derivative of. So I have for you a picture here, which again, you might want to draw for yourself. So this solid is formed by adding a right circular cylinder and then adjoining 2 hemispheres. So again, a hemisphere is half a sphere. So here's the first hemisphere on the top, and here's the second hemisphere on the bottom. Then I kind of, showed you another little picture there of what happens if you popped the 2 hemispheres off. Then I have for you some important reminders about formulas. So the volume, this is of a sphere. Hopefully it would make sense to you that if you add 2 hemispheres, you get 1 sphere. And again, in future problems, let's say you only added a hemisphere to the top or only to the bottom, you would have half of that formula, not the entire thing. It's only because you're adding a hemisphere on the top and the bottom that you wind up getting the whole volume equation. And then the surface area formula of a sphere is 4 pi r squared. So again, if these are formulas that you are not familiar with, highlight them, write them down, make sure that you know where they are in case you need them later. Spoiler alert, if you take a quick look at the formulas for volume and surface area, how do you take the volume and get the surface area? Well, if you look closely, you take the derivative. Remember, a volume is a cubic equation, a surface area is a quadratic equation, so it should make sense that if you take the derivative of the volume, you wind up with the surface area. So just kind of a nice tip for you in case you need it later. And just a reminder that the formulas that I just showed you, those are only for the sphere and the hemisphere. In order to find the total surface area or volume of the figure, I'm going to go ahead and have to add that to any parts of the cylinder. So I'm going to need a surface area and a volume. I'm going to go ahead and start with a volume. So to find the volume of the total figure, I'm going to start with the cylinder. So the volume of a cylinder is pi r squared h. A little color coding for you. Remember, because you have a bunch of circles stacked on top of each other, the area of one circle is pi r squared, and then times the height would give you the volume. So that's the cylinder. Then you would have to add the volume of the 2 hemispheres. Again, because 2 hemispheres are equal to 1 sphere, it's fair to say that you can simply just add the formula for the entire volume of a sphere, which would be 4/3 pi r cubed. So there's my volume equation. I'm going to need that, but I'm going to go ahead and just leave that there for a second. So the next thing that I need is I need a surface area equation. And again, to find the surface area equation, you're going to have to add up all the different pieces. So starting with the cylinder. So the cylinder, if you were to go ahead and unwrap this, just like we did in the previous problem, you would get a rectangle. The length would be 2 pi r, which would be the circumference of the circle, times height. So 2 pi r h. And again, just a little bit of color coding. That is the surface area of the cylinder. Then you're going to add to that the surface area of the two hemispheres. Again, because two hemispheres make one sphere, that's why you know that it's pi r, or 4 pi r squared. So I now have my two equations. What information have I not yet used? I have not used the fact that the total volume of the solid is equal to 12. So I'm going to go back to my volume equation here. I'm going to set it equal to 12. And I'm going to have to take this and resolve it for either H or R. And then I'm going to have to substitute it into my surface area equation. Again, hopefully it's easy for you to see why solving for H is optimal here, because there's only one of them. So if I'm going to solve for H, I'm going to start by doing 12 and then subtract 4/3 pi r cubed. Then to get the H all by itself, I would have to divide. So 12 minus 4/3 pi r cubed divided by pi r squared. That's going to be equal to H. And that is what I'm now going to have to plug into the surface area. Remember, because surface area is the thing that you're trying to minimize, that's why that is the primary equation, which is the one that you're ultimately going to have to take the derivative of. So now that I have this information, I'm going to go to my surface area equation. Everywhere that there is an H, I'm going to substitute in this whole thing. I know that this H looks a little bit messy, but I promise once we plug it in, lots of things should kind of cancel and turn out to be on the nicer side. So surface area is equal to 2 pi r. I'm going to substitute in that whole H value. So 12 minus 4/3 pi r cubed all over pi r squared. And then don't forget to have your 4 pi r squared as well. So just like in the previous problem, I am going to distribute this 2 pi r and then also split up that denominator just so that it's a little bit easier for me to see. So surface area is going to be equal to, if I go ahead and multiply, I can see that I am going to get 24 pi r, and that's going to be over pi r squared. Then minus 8/3 pi squared r to the fourth over pi r squared plus 4 pi r squared. So some simplifying can obviously happen here. In the first expression, I can go ahead and divide away these pi's. And then r to the first over r squared. I'm going to go ahead and rewrite that in a slightly nicer fashion. So 24. And then if you have more r's on the bottom, you'd have an r to the first on the bottom, but I'm going to write that as r to the -1. Remember, that's going to be a little bit friendlier when I go to take the derivative. Then minus, I can get rid of this pi and turn this into pi to the first. I can get rid of this r squared and turn this into r squared. And then this 8/3, I'm going to just rewrite it so that instead of all being in the numerator, I'm going to write it as a constant out front. So 8/3 and then pi r squared. And then plus 4 pi r squared. So then from here, I know it's a little hard to see, but you actually do have common factors. If you have 8/3 pi r squared and 4 pi r squared, those are both technically r squared. So I'm going to simplify that by finding a common denominator. So if I go to find a common denominator, this is over 1. So the surface area is equal to 24 r to the -1 minus 8/3 pi r squared plus 12/3 pi r squared. And again, that's what I got by just taking 4 and rewriting it as 12 over 3. So the surface area is equal to 24 r to the -1. -8/3 plus 12/3 would give me a positive 4/3 pi r squared. Let me just double check and make sure that that is all correct. Yep, looks good. Okay, so now we are finally ready to take the derivative. So 24r to the negative 1, bring down the negative 1, which would give you negative 24, and then to the 1 less power. Plus, bring down the 2 times 4/3 is 8/3 pi, and then r to the 1 less power, which would just be r. I'm going to go ahead and set that equal to 0. I'm going to go ahead now and put them on opposite sides. And when I put them on opposite sides, I'm also going to take that r to the negative 2 and move it to the denominator. So I'm going to move the 24 to the left, and I'm going to put the r squared on the bottom. And that's going to be equal to 8/3. And then I'm going to put the pi r on top as well, just because that's going to be easiest when I go to cross multiply. So that's what I'm going to do now. I'm going to go ahead and cross multiply. So when I do that, I'm going to get 3 times 24, which is 72. And that's going to be equal to 8 pi r cubed. If you look at that, I can go ahead and divide both sides by 8. So that's going to be 9 equals pi r cubed. Then I'm going to divide both sides by pi. So 9 over pi is equal to r cubed. How do you get rid of a cubed? You take the cube root of both sides. When you're taking the cube root, you don't need a plus or minus because you're taking the cube root of a positive. It has to just be the positive. So the cube root of 9 over 11, that is in fact my answer. You should have a unit, which in this case would be centimeters. And you're welcome to find that decimal answer if you want to. If you're going to find it, just do it very, very carefully. But honestly, if you just want to leave it as the cube root of 9 over 11, that would be perfectly fine with us, and probably even better since you don't run the risk of plugging it in your calculator incorrectly. So it's true for sure that these problems take a while. But again, we're focusing on quality over quantity. So just like you had 2 problems here, you're going to have 2 problems tonight. The main thing that I would make sure that you focus on tonight is whether or not there is a top on your figure. So keep that in mind. And again, if you have a question tonight that's talking about the cost, my suggestion would be to first start by finding the equation for the surface area. And then if you want to find an equation about how much that costs, you then have to multiply each piece of that times the cost, because that'll tell you how much you have to pay for each part of the area. And that's how you turn it into a cost equation. So thanks very much for tuning in, guys. And we will catch you next time.